Hello, fabulous fifth graders. This is Mrs. Ellis from Martin City, and today we are going to be practicing adding and subtracting fractions. And we're going to be looking at it through some word problems and focusing on estimation and checking to make sure our estimates are reasonable. So as we begin our work, I want to point out that each problem that we do together in our video today, as well as the problems in your independent practice, have a part A and a part B. Please make sure you do the part A first because we need to make sure we are estimating before we are solving. So let's take a look at the problem that we have here. Levi has 5 feet of wrapping paper. He then used 1 3/4 feet to wrap a box. How much wrapping paper does Levi have left? When I think about this situation, I know that I'm starting with an amount and then I'm using some of that amount. So that's going to be a subtraction situation. So let's take a look at the estimate here. They've given us an estimate. They say Levi has about 2 feet of wrapping paper left, and our job is to determine, is this answer reasonable? Well, I know I've got 5 feet to start with, and this is how much Levi used. So I'm going to kind of think about rounding. If I had 1 3/4, that's closer to 2 than it is to 1. So in my estimating, I'm thinking, okay, 5 minus 2. He used about 2 feet. So my estimate would be that he has 3 feet of wrapping paper left. So I would say no, this estimate is not reasonable because my estimate would be 3. Now on to part B. Let's go ahead and solve this word problem. So we know that we are starting with 5 feet. And then I know that Levi used 1 3/4 feet. So I have to kind of think here, I'm going to rename this 5. I'm going to just change its name so that I can make more sense out of it. I'm going to turn this into a 4 4/4. We're fifth graders. We've been working on fractions for a long time, so we're pretty clear about how 4 4/4 is the same thing as 5. It's just a different name. But by renaming 5, I'm able to turn this into a much simpler subtraction problem. So if I have 4/4 and I take 3 of those fourths away, what's left is 1/4. And then I think about my whole numbers. If I had 4 whole feet of wrapping paper and used 1 foot of wrapping paper, there would be 3 feet left. So 3 1/4 feet is the correct answer. Let's try another one of these word problems. Here we've got Layla. Layla drank 1 2/4 cup of lemonade. And Niya drank 1 2/5 cups of lemonade. How many cups of lemonade did they drink altogether? So part A, we're supposed to say whether this estimate is reasonable. Layla and Niya drank about 3 cups of lemonade. This is the estimate that they give us. Well, let's see. 1 2/4. I would round that to be up. That's about 1.5. I would round that to be about 2. And 1 2/5. Well, I know 2/5 is less than a half, so maybe I'm going to round this one down to about 1. So this problem is about 2 plus about 1. And if I think about that estimate, that makes about 3. I would say yes. this estimate is reasonable. Now we have to go ahead and solve this problem. So I have 1 2/4. I'm going to add 1 2/5. Now I know that I can't add fourths and fifths together. They're not the same unit. So I have to turn them into a common unit. I have to think about what equivalent fractions could I make where they would have the same unit. So I'm going to think about 2/4 and 2/5. I know that fourths and fifths can both make 20ths. So I'm going to try to make 20ths out of this. And I think to myself, okay, if 4 popped into a mystery box and came out as a 20, I know it got multiplied by 5. And to keep my fractions equivalent, whatever I did to my denominator, I have to do to my numerator, and 2 times 5 is 10. Let's try down here with 5. To turn 5 into 20 using multiplication, I need to multiply by 4. So I need to carry out that same thing with my numerator, and 2 times 4 is 8. So over here I have 10 20ths plus 8 20ths, which makes 18 20ths. But don't forget your whole numbers. 1 plus 1 is 2. Now, some of you super smarties ready for 6th grade are noticing here that 18 and 20 are both even numbers. They both have 2 as a factor. I could simplify this answer to be 2 and 9/10. But both of these are the same. They're equivalent. So I would accept the answer 2 and 18/20 or 2 and 9/10. I recommend you do what your math teacher usually expects from you as far as simplifying fractions. Again, we have 2 parts, a part A and a part B, but this time we're actually going to be making the estimate. Darren has 2 5/8 gallons of red paint and 1 5/6 gallons of blue paint. How many gallons of paint does Darren have altogether? Well, I'm going to use some rounding to help me figure this out. So 2 5/8. When I think about 5/8, I know that that is greater than a half, so I'm going to kind of round this one up to 3. He has about 3 gallons of red paint. Now let's try 1 5/6. 1 5/6 is rather close to 2. It's only 1/6 away. So I would round that up to 2 gallons of blue paint. And I would estimate that Darren has 3 plus 2, or 5 gallons of paint. But now we have to take a look back at part B and solve the problem. So I have 2 5/8. And we're going to add 1 5/6. Now again, I have a problem where I don't have the same unit. 8ths and 6ths cannot be added together because they are not the same. I have to find equivalent fractions that have the same unit so that they can be, well, let's see, added together. So I'm going to make myself a little list. Let's think about things that we know about 6 and 8. I know I could multiply these together and get 48ths, but I'm going to think about what I know about multiples of 6 and 8 to see if I can come up with a common denominator that might be a little bit simpler to work with. So I'm going to think about everything I know about 8 and 6. And I'm going to just skip count by both 8 and 6, find their multiples, and see if I can find that common denominator. So I'll start with eighths. 8, 16, 24, 32, 40, 48. Now I'll try listing sixths. 6, 12, 18, 24, 30, 36, 42, 48. So as you can see here, 24 is a multiple that's on both lists, and so is 48. Both of these numbers will work, but I'd rather be working with a smaller, simpler number like 24. So I'm going to go ahead and turn these eighths and sixths here into equivalent fractions that have 24 as my denominator. So I'll just set these up here. And now I have to go back and think, all right, so if I needed to make 8 into a 24, I know that I need to multiply that 8 by 1, 2, 3. 8 times 3 is 24, and I need to keep it equivalent by doing the very same thing to the top. 5 times 3 is 15. Let's go ahead and check out our 5 6. I know that to turn my sixths into 24ths, I need to multiply by 1, 2, 3, 4. 6 times 4 is 24. And I will do the same thing to the top. 5 times 4 is 20. 20. When I add that together, 15 24ths plus 20 24ths, I know my answer is still going to be 24ths, but my numerator is going to be 35 24ths. Let's not forget our whole numbers. 2 plus 1 is 3, and so our answer is 3 and 35 24ths. Now you might be saying, Miss Ellis, that doesn't make sense. What's a 35 24th? Well, this is technically the correct answer, but we can put it into a simpler form to better communicate our ideas. So I know that 35 24ths is greater than 1, and I am going to break this fraction down. I know that 24 24ths is the same thing as 1 whole, so I can turn this into 1 whole. And if I took 24 24ths out, there would be 11 24ths left. So I need to combine these. 3 plus 1 is 4, and 11 24ths. Let's check it with our estimate. Yeah, pretty close. Okay. Sonia's goal is to run 5.5 miles in 2 days. She ran 10/3 miles on day 1. How many more miles does she need to run to meet her goal? And we're going to start, of course, with part A, and we're going to estimate first. This one's a little tricky. I can think about 5.5. I can kind of picture that in my head, but 10/3? 10/3 is hard for me to really picture in my head. I'm having a hard time thinking about how much that is. Part of the reason for that is this is a fraction greater than 1. So I know that 10/3 is equivalent to, well, I could get 3 groups of 3. And there would be 1/3 left over. 10/3 and 3 1/3 are equivalent. So now I can kind of think about it like this. If I had about 5.5, I might round that up to estimate to be about 6. And 3 1/3, since 1/3 is less than 1/2, I would round that to be about 3. And we've got a situation where we need to figure out what is left. How many more miles does she need? So this estimate needs to be 6 minus 3. 6 minus 3 is approximately 3. My estimate should be 3. Now it's time for us to talk about part B. Okay? So I still think it's going to be easier to work with this 3 1/3. So I'm going to set my problem up with 5 1/2. And I'm going to subtract 3 1/3. Now, again, I can't take away 3 1/3 from 5 1/2. I just can't do it. They're not the same unit. So I have to turn these into equivalent fractions that have a common denominator. When I think about halves and thirds, I see right away that I can turn both of those into sixths. And I'm hoping by this part of 5th grade, you can see that right away without having to list out our multiples. So my goal here is going to be sixths. Now, what do I need to do to a 2 to turn it into a sixth? That gets multiplied by 3. And I do the very same to my numerator to turn this into 3/6. What about down here with a third? A third gets multiplied by 2 to make sixths. And 1 times 2 is 2. So now I have a situation where I've got 3/6 minus 2/6. That leaves me with 1/6 left over. And I must also do 5 minus 3. 5 minus 3 is 2. So 2 1/6. She needs to run 2 1/6 more miles. All right, guys, last one. And this one is very interesting because for their part A, they want us to do this without calculating. So that sounds pretty great. We like that, right? But then in part B, we're going to need to explain our thinking. I'll help you with that so you'll know what to do on your independent practice. So we're supposed to solve this problem without calculating. Brett and Irving need 2.5 meters of fabric to make a large pillowcase. Brett has 1 3/4 meters, and Irving has 3/2 of a meter of fabric. And we need to answer this question, do Brett and Irving have enough fabric? This is what they need. This is what they have. So, one thought I have without calculating about this situation is that Irving has 3/2 of a meter of fabric. And I know that 3/2 is equivalent to 1 1/2. So if I think about what Irving has 1 1/2, and altogether they need 2 1/2. So just with what Irving has, they're only 1 meter away from what they need. When I look back to the problem and see how much Brett has, well, does Brett have more or less than 1 meter of fabric? He's got more. So they have more than enough to make their pillowcase. Yes, they have enough fabric. Now, how am I going to explain my thinking? Well, what was my first step? My first step was better understanding this fraction here. So I could say, I know that Irving has 1 1/2 meters. That means they only need one more meter. Brett has 1 3/4. So, yes, they have enough. All right, guys, that's the end of our video for today. Hopefully, walking through these problems will really help you with your independent practice. We've been working on fractions this week, and we've done a lot of fractions work this year in 5th grade. This is a great time to just solidify your learning. I look forward to seeing the answers you come up with in your independent practice.